Hey, PCCL channel greets you. A video on molar mass. What does molar mean? I must tell you about the mole first. If we had to work with the masses of proton and neutron, to get the mass of an atom and do all the chemistry exercises with numbers like that, admit that it could become difficult. Avogadro's constant. Why is this number associated with the other numbers? He is there to simplify everything. Take your calculator. Multiply the mass of the proton by the Avogadro's constant. You get 1 gram. And it becomes very simple. This quantity, 6.02 times 10 to the 23rd, is called the mole. You have just calculated the mass of a mole of protons. And since the proton and the neutron have roughly the same mass, you calculated the mass of 1 mole of nucleons, which is 1 gram. All in all, an easy number to remember. 1 gram per mole is easy to remember. The mass of 1 mole of carbon-12, since there are 12 nucleons, 6 protons and 6 neutrons, is 12 grams. 12 nucleons, therefore 12 grams. The definition of mole says that it is the unit of quantity of matter, symbol mole, containing exactly 6.02 times 10 to the 23rd elementary entities. Rather than counting grains of sand, we count in wheelbarrows. It's the same. Moles are on our own scale since we can measure them with a laboratory apparatus. The notation. The number of moles, for example of methane molecules, if it is 0.284 moles, well, I write it like that. What I said for carbon-12 is valid for all entities, all particles. After what I just said, you say to yourself, if we know the number of nucleons of an element, its molar mass is a whole number, since the number of nucleons is a whole number. There it is, the letter A, top left, in yellow in the table. Let's see this together. For beryllium 9 grams per mole. A whole number. For fluorine, 19 grams per mole. Another whole number. Sodium 23. Aluminum 27. Phosphorus 31. But I haven't told you yet that in nature there are what are called isotopes. I start with hydrogen. Hydrogen, with a single proton without a neutron, is very predominant. It is the most abundant. But, there is still this small percentage there, of hydrogen 2, with 2 nucleons. A neutron in addition to the proton. These 2 hydrogen atoms are isotopes. Z equals 1, the number of protons is the same for both. We therefore call them both hydrogen because the name is determined by the atomic number Z. So, as it is in the majority, rounded to the 10th, that does not change anything. And there the molar mass is equal to the mass number. Whole number. For helium. It also works because helium-4 is very predominant. I accelerate. For lithium. It works less because here the 7.5% is not negligible when we round to the 10th. Beryllium. Already seen. For boron. Did you get the math by the way? That's the percentages. The 19.9 which is there, it's it. And the 80.1 which is there. It's it. Carbon, the famous carbon. With carbon-14, the very famous carbon-14 which is used to date the remains of organic matter. The most abundant is carbon-12 in nature. So when you do the math, you find 12 grams per mole. I'm going faster. You will stop the video. Don't memorize all molar masses. They will be given as data in the instructions. Three isotopes for magnesium. Only one for Al. Silicon has 3 isotopes. Phosphorus has only 1. Chlorine. A great classic one. Stop there because you may be asked to do this calculation during exercise. It's a standard. And finally, argon. That's it for this video. Thank you.